Alright, so this is where this section gets a little bit more complicated. So each shell, right, the electrons are one shells around the atom. Each shell I want you to think of as being made up of different orbitals. Imagine that the orbitals are like compartments within the shell that can hold electrons. So if you look at the second shell, it holds 8 electrons. So those 8 electrons go into 2 different little compartments. And each of those compartments is an orbital. One's called the s orbital, one's called the p orbital. So some will go into one of them, some will go into the other. That's what these orbitals are. Let's get a second here. Orbitals are named S, P, D, and F. Scientists are very creative, so we named the 4 of them after letters. And any shell within an atom may have one or more of these. So the first shell has an s orbital. The first shell only has one orbital, so both the electrons, the 2 that go into the first shell, go into the s orbital in that shell. Second shell has an S and a P orbital.
Aren't they annoying, but shouldn't there be
And S.
AN, like
S. Pronounced S. And S orbital. A S orbital goes inside there.
Yeah, I know, but like that's not like.
I forget. Third shell has N, S, P, and D orbitals. All right. We're only going to go up to the third shell today, so that's where I'm going to stop. One more thing you need to know, and then we'll actually start using this and try and make some sense out of it. So the orbitals, and for example, every shell has an S orbital. So the first shell has an S orbital, second shell has an S orbital, third shell has an S orbital. Depending on the particular orbital, tells you how many it can hold, how many electrons it can hold. So the S orbitals, I should use quotations again. S orbitals hold 2 electrons. So for each shell, if it has at least 2 electrons, 2 will go into the S orbital. P orbitals by the way, if you're really on top of this stuff and you're thinking about this, the first shell only holds 2 electrons, and the S orbital only holds 2 electrons. So that tells you the first shell is just made up of that S orbital. That's why it only holds 2 electrons. P orbital, they hold 6 electrons. This makes sense for the second shell, which has an S and a P orbital. 2 plus 6 is 8. That's why the second shell holds 8 electrons. Because 2 go into the S orbital and 6 go into the P orbital. D orbitals hold 10 electrons, and F hold 14. Okay, so So trying to show you what this would look like. Imagine if we drew phosphorus, okay? So phosphorus is atomic number 15. And if I drew the atom, what I would draw for you is 15 protons, 16 neutrons, and then it's going to be 2 electrons in the first shell, 8 electrons in the second shell, and phosphorus is in the third row. So it's going to be 1, 2, 3, 4, 5 electrons in the third shell, right? So that's an atom of phosphorus. So just imagine that each of these shells here, in fact, let me space these out a little bit more. Imagine that each of these is made up of separate parts. Okay, so the first shell is made up of 1 part, so ignore that. The second shell here has 8 electrons, but those 8 electrons are in 2 different places. There's a 2s orbital and a 2p orbital. Those are the 2 orbitals in the second shell. They have 2s because they're in the second shell. So it's really like 2 separate shells that are very close together. And this s orbital can hold 2 of the electrons, and this p orbital can hold 6 of them. So that's where the 8 electrons are. They're broken up into those 2 orbitals. So imagine it's like a closet that has 2 compartments within it. You can put some stuff in one compartment and some stuff in the other. It's the same thing. The second shell has 2 compartments. One's the s orbital, one's the p orbital. And then the same thing over here for the third shell. Instead of having these 5 in one place, some of them are going to go into the 3s, and some of them are going to go into the 3p. So 2 of them are going to go there, and the other 3 that are left over are going to go there. So there's your 5 electrons in the third shell. Got it so far? Okay. Now let's talk about how we're actually going to write this stuff. Once we do this, where are you at?
I just got done with that one.
Did you get to here?
Yeah.
Okay, good. Let me erase the top. Okay, so all we want to do is we want to write this stuff down so we can tell where the electrons are, which orbitals they're in. So this will be called electron configuration. Okay. Now we're of course going to start with hydrogen. Hydrogen is atomic number 1. If I wanted to draw hydrogen, I'm going to draw it first. I would draw a proton in the middle and an electron on the outside, right, floating around it, 1 electron. Okay, so this 1 electron is going to be in the first shell. It's got to be in the s orbital because the first shell only has an s orbital. So I'm going to write 1, s, and then it's 1 electron, so I'm going to put a little superscript 1 there. So write it down, and then we're going to explain all 3 of them. In fact, let me move it over a little bit so I got more space, because I'm going to circle each of these and label them. So 1, s, 1. So the first thing, the 1 here, this is the shell. So the big number at the beginning is always a shell. It's the first shell, so it's a 1. The letter is going to be the orbital. And then this little superscript means like an exponent, right? That's going to be the number of electrons. Number of electrons. Okay. Let's do a bunch more of these now. Let's do helium. So helium, 2 protons, 2 neutrons, 2 electrons right there. So what am I going to write for the electron configuration for helium? Right, 1s2. 2 electrons in the s orbital of the first shell. Now let's do lithium. So lithium, and forget the nucleus, I'm just going to draw the electrons, has 2 electrons in the first shell and 1 in the second. So what am I going to write for lithium? What? Okay, so think about this. Those 2 electrons are where? First shell. So first thing we'll do is write 1s2. That's these 2 electrons here. And then 2s1 tells me that there's 1 electron in the s orbital of the second shell. So 1s2, that's these 2 electrons here in the s orbital of the first shell. 2, second shell, s orbital of the second shell has 1 electron. Let's do some more. It makes more sense as you do more. Let's do beryllium. Okay, beryllium, 2 electrons in the first shell, 2 in the second shell. What am I going to write? 1s2, that accounts for these 2. 2s2, that accounts for the other 2 electrons. Let's do boron. Boron, and we don't have to draw these atoms every time. I'm just drawing these to show you how the orbitals relate to the actual atom. After a few, I'll stop drawing them. 2 in the first shell, 3 in the second shell. So what am I going to write for boron? 1s2, that takes care of the 2 in the first shell.
2s2.
It's 2s2 because the s orbital only holds 2 electrons. So it's 2s2, that's 2 of these, and then what? 2p1, that's the last electron. So this section here, 2 and 2, these are both the second shell, that accounts for these 3 electrons. 2 are in the s orbital, 1's in the p orbital.
The P has 6.
P fits 6. So as we go through the rest of the second row, we're going to be filling the p orbital. Let's do carbon. What am I going to write here?
Or 2p2.
2p2. So this is 4 electrons in the second shell in carbon, right? 2 in the first, 4 in the second. There's your 2 electrons in the first shell. There's your 4 electrons in the second shell. Let's keep going. Let's do nitrogen. What do I write here? 2p3. The p orbital can hold as many as 6, so we can keep filling the p for a while. So this nitrogen is what? It's 2 and 5. Those 5 there are right there. 2 in the s orbital, 3 in the p orbital, both the second shell. All right, let's do oxygen, just because I like overkill. What am I going to write? 1s2, 2s2, 2p4. This is 6 in the second shell, right? 2 and 4, that's 6. 2, whoops, not 4, 6. Just like 6. How many people are getting this so far? All right, good. Let's jump ahead. Let's start with the third row. Let's do sodium. That's atomic number 11, right? So sodium is going to be 2, 8, and 1. So what are we going to write? 2p6.
And 3s1.
3s1. See, 2s2 and 2p6, that adds up to 8. 2 and 6 is 8, that's your 8 electrons in the second shell. 3s1, that's your 1 electron in the third shell. Should I do more? Yes? Let's do magnesium. I'm going to write it. By the way, you notice for every, for the periodic table, right, these 2 rows are kind of separated here, right? Yeah. So, if you notice, this is 2 wide because every row starts out with an s orbital, every shell, right? So it's always going to be the s ones that are filling here. This is 6 across, right? That corresponds to the p orbital. So when we do magnesium, that's going to be 3s2, right? I'll show you. All right, so magnesium, that's 12. Let's draw it over here just because I like drawing 2, 8, and 2. Okay? So what am I gonna write here?
1s2, 2s2, 2p6, 3s2.
That's it. There's your second shell, there's your first shell, here's your third shell. 2, 8, 2. Aluminum. Oops, that's a 3. 1s2, 2s2, 2p6, 3s2, 3p1. Silicon is going to be 3p2, phosphorus is going to be 3p3, and so on. It's just the end of the exchange. Again, it's helpful if you look at the periodic table. Kind of makes a little bit of sense. Questions? We good?
So the N will always have that base of 3,
I'm sorry, where?
or like that, yeah.
So yeah, the third row is going to finish with these, right? So as we go across the third row, it's going to end with 3p up till argon. Once we start the fourth row, it's going to be 4s when we're starting this. All right. Today you only got to do up to atomic number 18, so you don't have to worry, because afterwards you start to go out of order. And that I will talk about tomorrow. Good?
Good.
All right.
Might as well copy the